Hello, welcome to another lecture. In this lecture we will see discrete Fourier series. So we know any continuous time periodic signal xt can be written as weighted sum of complex exponentials, where these weights are known as Fourier series coefficients ak. This was our continuous time Fourier series. So by sampling this time domain signal xt, we will get samples of xt which will be xn, and sampling in one domain results periodicity in another domain. So this ak became periodic in frequency domain, that will result in discrete Fourier series. So as we will take samples of xt, it became xn and ak became periodic. So this is discrete and periodic in both time as well as frequency domain. So discrete Fourier series and discrete Fourier transform both are same, only the difference is that the procedure of making discrete Fourier series is different from the procedure of making discrete Fourier transform. We make discrete Fourier transform by sampling in frequency domain, and we make discrete Fourier series by sampling in time domain. And we have to remember these 2 points, that sampling in one domain results periodicity in another domain, means if signal is discrete in one domain, it will be periodic in another domain, and continuous in one domain, it will be aperiodic in another domain. Continuous in one domain will be aperiodic in another domain. So let us see difference between this discrete Fourier series and discrete Fourier transform. What was discrete Fourier transform? There was a signal, discrete time signal xn, something like this, and its dtft, discrete time Fourier transform dtft e to the power j omega was continuous and periodic in frequency domain up to infinity. This was its dtft from minus infinity to infinity with periodic 2 pi. This was minus 2 pi. This was dtft, and when we take samples of spectrum of dtft, means this x e to the power j omega, when we do sampling in frequency domain, it became periodic in time domain. Then this was x of k, this x e to the power j omega turns into x of k with fundamental period n, and when we take samples in frequency domain, it became periodic in time domain. So this was our xn. So this was procedure how we make discrete Fourier transform from dtft. We take samples of spectrum of dtft, and signal became periodic in time domain as well as in frequency domain, and discrete in frequency domain as well as in time domain. But in discrete Fourier series, we take samples of signal in time domain which was having continuous Fourier series discrete in frequency domain, and we take samples in time domain, it became periodic in frequency domain and periodic in time domain also, and it became discrete in time domain and discrete in frequency domain also. So for discrete Fourier series, its analysis equation is derived from continuous time Fourier series analysis equation. In continuous time Fourier series, AK is given as 1 upon T integration T xt to the power minus jk omega naught t dt. So by replacing this xt with xn and period changes from t to n. Now analysis equation became AK equal to 1 upon n summation n0 to n minus 1 xn e to the power minus jnk 2 pi by n. Synthesis equation is also calculated from the synthesis equation of continuous time Fourier series. In continuous time Fourier series, xt is given as summation k minus infinity to infinity ak e to the power jk omega naught t. Here xn became k0 to n minus 1 ak e to the power jnk 2 pi by n. As it is periodic with period n, so we are taking k from 0 to n minus 1. Let us see one important result for endpoint DFT and FFT. In DFT, number of multiplication are n square. For endpoint DFT, number of multiplication are n square and number of addition are n into n minus 1. And in FFT, for endpoint FFT, number of multiplication are n by 2 log base to n, and for endpoint FFT, number of addition are n log base to n. So let us stop this module here. Thank you.